Good morning, class. Today we're going to discuss what actually happened with yesterday's video. Now, some of you left some very excellent answers in the question that I proposed to you, but it's actually a fair bit more complicated because it's not actually one simple reaction. There are three separate reactions that are causing this to work. The first reaction is as we see here. The first reaction is when baking soda, otherwise known as sodium bicarbonate, reacts with water, and when it does, it creates some sodium hydroxide, a base, and some H2CO3, also otherwise known as carbonic acid, or hydrogen carbonate. Now, carbonic acid does something interesting. Carbonic acid on its own decomposes, so it actually has a second reaction that occurs right away. So our second reaction that occurs right away here is our carbonic acid decomposes into water and carbon dioxide gas. Now, the funny thing about this is when you have baking soda react with water, the sodium hydroxide and carbonic acid decomposes. Why don't we have vinegar? We use vinegar in our demonstration. Well, let's do a little experiment and see, can we do this without vinegar? Here, you can see that I'm taking some baking soda and I'm adding some water and mixing it up. Then I light a match and I put that match into the area. The match, however, you can see is staying lit. Where's the carbon dioxide extinguishing the flame? I thought this reaction was supposed to happen. But now we're going to take some vinegar, add it, there's a lot of bubbles, so much CO2. Now when I light a match and put it into the cup, boom, that flame just extinguishes right away. So why didn't the flame go out when we had just regular baking soda and water? It's supposed to produce carbon dioxide. Clearly, it didn't produce enough carbon dioxide to put out the flame. So what does vinegar have to do with this? Does vinegar produce more carbon dioxide? Well, let's take a look at what vinegar would react with. Vinegar is also known as acetic acid, and acetic acid would react with the sodium hydroxide. So we'd see that our vinegar is reacting with our sodium hydroxide. And this is a neutralization reaction, and we know all neutralization reactions create a water and a salt. In this case, the salt is sodium acetate. But this is odd. That's not any extra carbon dioxide. If the vinegar isn't creating carbon dioxide, and our first reaction didn't make enough carbon dioxide, what is vinegar doing here? Why is it helping things move along with making enough carbon dioxide to put out the flame? The key here, our baking soda only will react with water a little bit at a time. This is because it has something we call a low solubility, and understanding solubility will help us understand why vinegar makes this reaction happen even though it's not producing carbon dioxide itself. I find a good analogy is that solubility is like the bouncer at a water party. Take a look at this situation. We have a bunch of sodium bicarbonates wanting to enter the water party, but the solubility will only let a certain amount in at a time because the solubility bouncer doesn't want too many sodium bicarbonates getting into the water party because then it'll get too crowded. So he'll let in one sodium bicarbonate, and that will produce some sodium hydroxide and carbonic acid, and then that carbonic acid will decompose into water, which is perfectly fine at the water party, and the carbon dioxide, which goes off into the air. But now the solubility bouncer will not let any more sodium bicarbonates in because there's too many sodium hydroxides already in the party. This is where vinegar comes in. Vinegar is going to come in and going to react with the sodium hydroxide. And that will mean that there are no more sodium hydroxides in the water party, and the solubility bouncer is going to let more sodium bicarbonates in. Those sodium bicarbonates are going to then react to decompose into sodium hydroxide and carbonic acid. And this carbonic acid would again decompose into water and carbon dioxide. And the vinegar, which is still around, takes the sodium hydroxide out of that water party, allowing more sodium bicarbonates to come in, which will again produce more and more of these products of carbon dioxide. The production of the carbon dioxide that's going to put out the flame is actually caused by the reaction of sodium bicarbonate reacting with water. The vinegar is going to take the sodium hydroxide out of the water to allow more of the baking soda, more of the sodium bicarbonate, to dissolve and react with the water. This is just our first look at an idea called solubility. We're going to play with this a little more. I hope you found this really interesting. Have a good day.